Hi everyone, welcome to Go Classes. In this lecture we will see how to translate English statement into first order logic expression. Okay. So if there is a English statement given, so let's assume that we have a English statement. Some English statement we have, for example, maybe like all crows are black. So this is an English statement. Now we need to study how to convert this English statement into first order logic expression. Okay. So if you have any English statement, let's call it P. So this is an English statement. Now we want to translate this P, which is English statement, to first order logic expression. Okay. So let's call it shy. Okay. So this is a mathematical expression, or you can say first order logic expression. So we want to write the corresponding first order logic expression for this English statement P. Okay. So this is the English statement. Now, first of all, what is the meaning of this translation? Let me tell you. So first we should understand what is the meaning of translating English statement to first order logic expression. So remember, it means that this English statement is basically similar to first order logic. This first order logic expression means this P, this English statement, this is equivalent to this mathematical expression. Okay, this first order logic expression psi. It means that whenever this English statement is true, then this mathematical expression also should be true, and whenever this English statement is false, then this mathematical expression should also be false. So this is the meaning of conversion of English statement to first order logic expression. Okay, so very simple, remember. So if you have this statement, all crows are black. Now this is an English statement. We want to write down the corresponding first order logic expression. So corresponding first order logic expression, it means that whenever this statement is true, means whenever all crows are black, then this mathematical expression that we will write, this also should be true. Also, when this statement is false, means when there are some crow which are not black, okay, then our mathematical expression also should be false. So this is the meaning of writing equivalent mathematical expression for the given English statement. Okay, so this is the first point to understand. Now let's see the second point. Most of the time in first order logic we encounter this type of statements. Okay, so four type of statements we encounter most of the times. Okay, so four fundamental type of statements that we encounter are like this type of statement: or P's are Q's, some P's are Q's, no P's are Q's, some P's aren't Q's. Okay, so these are four fundamental type of statement that we encounter in first order logic. Okay, so we need to see how to convert these English statements. Okay, so these four type of statements, how can we convert them into first order logic? Okay, so let's start with the first type, means this type of statement. Whenever you see this type of statement, all A's are B's. Okay, so if you see this type of statement, then how can we convert this into first order logic expression? One example is all crows are black. Okay, another example is all natural numbers are integers. All natural numbers are integers. Okay, so many such statements you can encounter. Okay, for example, all Indians are Asian. All Indians are Asians. Okay, so you can notice whenever you encounter this type of statement, then how can we convert? How can we write equivalent first order logic expression for this statement? Okay, so let's understand this by this example: all crows are black. So let's understand. All crows are black. Now this statement is saying that if you are a crow, then you are black. Basically, if any animal is crow, if any bird is crow, then that is basically black. Okay, now you can notice the domain is not given in first order logic we need a domain. So let's assume, first of all, when domain is not given, then remember that the domain consists everything. So this is the first point that we should note. It means when domain is not specified, okay, when domain of some first order logic expression is not specified, then it means domain contains everything. So this is the point. When domain is not specified, then domain contains everything. Okay. Now, so here you can notice the domain is not specified. So let's assume the domain contains everything. It means in the domain you have crows. So let's assume these are the crows. So you have all the crows also you have. For example, A, B, C, let's assume these are the crows. So in the domain you have all the crows and there are all the non-crows also. So domain contains everything. It means all the birds, all the animals, all the people, everything is in this domain. Okay, everything is inside this domain. In this domain you have crows also. Now, so this is saying all crows are black. I can write this statement like this: for everything in the domain. So I can say for every element in the domain. For every element in the domain, I can say that if it is crow, then it is black. Correct? So like this I can write. So this statement and this statement both are similar. Now, so we are saying that for every element in the domain, how can I write it? For every element in the domain. So let's see. It means for all x. Because it means, what this means? This means for every element in the domain. If this x is a crow, then it is black. If it is a crow, then it is black. So this is how we can convert this statement into first order logic. Okay. So very simple. For everything in the domain, it means for everything in the domain, if it is crow, then it is black. So it means every crow is black. Correct? Now, let's see why this is incorrect. Okay, for example, if I want to write this English statement into first order logic. All crows are black. Okay, so this is my statement. Let's call this P. Let's call this statement P. So this English statement, I am calling it P. Now, let's see why this translation is incorrect. Like, can I write this? For all x, crow and black. Can I write like this? Crow and black. Is this a correct translation? Okay. So this English statement, for this English statement, can I say this is a correct translation? Okay. So let's call this translation number 1. Let's call it 1. Okay. So now we want to check whether this translation, this first order logic expression is correct translation for, is equivalent to this English statement or not. You can notice one thing is that what this is saying. This is saying that everything in the domain is crow and it is black. So remember, this statement is saying that everything in the domain, for all x means everything in the domain. Okay. So everything in the domain is crow and is black. Everything in the domain is crow and black. This is not what we want. Okay. We want to say that all crows are black. Okay. If it is a crow, then it is black. This is what we want to say. But this expression 1 is saying that everything is crow and everything is black. Now let me tell you another logic. Okay, another reason why this expression is not correct expression for this English statement. So let me give you another idea. Okay. So you can notice, let's assume a scenario. I am giving you a particular scenario. I am giving you. So consider this scenario. Let's assume that all the crows are black. Okay. So these all the crows. Let's assume you have A, B, C, 3 crows you have. So these are the crows. And let's assume that all the crows are black. Okay. And this is the domain. Domain contains everything. So in the domain, let's assume you have some other bird. Maybe some other bird, D, E. Something else you have. Okay. Maybe some animal you have, D, E, F. Maybe these are the animals. Now consider this scenario where all the crows are black. Okay, so in this scenario I am saying that all the crows are black. Now if all the crows are black, so in this scenario what will happen? In this scenario you can notice that this statement, this English statement will become true, correct? This statement, because I am assuming that all the crows are black in this scenario. So in this scenario, this statement P, all crows are black, this will become true. But you can notice that this expression 1 will become false, because this expression 1 is saying that everything in the domain is crow and black. Okay, but you can notice that this expression 1 will become false because, for example, because this F, element F, this is an element in the domain. You can notice this is element in the domain, but this is not a crow. So because this is not a crow, so for this F I can say that crow of F will become false, because F is not a crow. So I can say that for this element F, or you can say for this element E, or you can say for this element D, for these elements you can notice that this expression 1 will become false. So you can notice that in this scenario our English statement is true, but our expression 1 is false. What it means? It means that this expression 1 is not a correct expression for this first order for this English statement. So this is the conclusion. Okay, remember this point. I told you the definition of when can we say that an English statement, when can we say that and first order logic expression is equivalent to English statement. So I told you this is an English statement, so this is equivalent to some first order logic expression. When can we say? So this is our English statement, and now I am saying that when can we say that this is equivalent to this first order logic expression? Or I can say that when can I say that this expression is correct expression for this English statement? Okay, so when can we say that? We can say that whenever P is true. Remember, whenever P is true, then this expression also must be true, and whenever P is false, then this expression also must be false. So this is the simple point. If this property is true, okay, whenever this English statement is true, then our expression must be true. Whenever this English statement is false, our expression must be false. If this property is satisfied, then we will say that this expression is correct expression for this statement, or we can say that this English statement is equivalent to this first order logic expression. Okay, but in this example, the example that we have taken, you can notice, okay, here you can notice that this expression for all x, crow x and black x, this expression is not a correct expression for this statement, because we can have a scenario where you can notice that our English statement is true, but the expression is false. So I can say this expression is not a correct expression for this statement. Okay, so this is the first point. Now let me tell you, now let me ask you, can I say this is a correct expression? Okay, all crows are black. Okay, and my question is, can I say this is a correct expression for all x if it is crow or it is black? Can I say this is a correct expression? Okay, just read it. So this is our English statement. Let's call it statement P, and let's call it expression 2. Now, can I say that this is a correct first order logic expression for this English statement? Again, the answer is no. Because what this expression is saying? This expression is saying that everything in the domain is either crow or is black. So remember, this is saying that everything in the domain is crow or black. But this is not what we want. What we want all crows are black. This is what we want. But this expression 2 is giving us something else. Expression 2 is saying everything in the domain is crow or black. Now again, let me give you some scenario where this statement and this expression, they will have different truth value. So consider this scenario. Just consider this simple scenario. Okay. Now assume this is your domain. So domain has everything. I told you, when domain is not mentioned, when domain is not specified, then domain has everything. And these are the crows. Let's assume inside this domain these are the crows A, B, C. And let's assume these are not crows. Okay, D, E, F. Now consider the scenario where you can notice that, let's assume that all the no crow is black. Just consider the scenario where no crow is black. Okay, so in this scenario I am saying that in this scenario no crow is black. Just consider this, no crow is black. And let's assume that all these known crows they are black. Let's assume, okay, all known crows means what is not crow, that is black. All known crow is black. Now consider this scenario. Okay, are you getting my point? So I am saying that in this scenario where no crow is black, also all the known crow, these known crow means which is not a crow, all these known crow are black. Now in this scenario, what will be the truth value of P? So this English statement, okay, you can see in this scenario no crow is black, so the truth value of P will be false. But in this scenario, what will be the truth value of expression 2, this first order logic expression? You can notice that the truth value of this expression will be true, because everything, you can notice, for all x, okay, for everything in the domain, you can notice either it you can see either it is a crow or it is a black. You can notice these are crow, so because of all these elements A, B, C, for these elements this will be true, this expression will be true. And similarly in this scenario I am assuming that all the known crow is black, so this is a black, this is black, this is black, so I can say that because of these elements, this will be true, so again this expression will be true. So what I can say? I can say that in this scenario our English statement is false but our expression is true. So what it means? It means that this expression is not a correct expression for our English statement. Okay, so this English statement is not equivalent to this mathematical expression. So this mathematical expression is also false. Now in a similar manner I can ask you, can I say this is true? All crows are black. Okay, this is our statement. Again let me call it P. This is our statement. Can I say this third expression, I am giving you another expression, can I say this expression is a correct expression for this statement? Double implication. Okay, so I am asking you, just think about it. Pause the video and think about it. Can I say that this expression is correct expression for this statement? Now again the answer is no. Why? First of all, what is this statement saying? This statement is saying that everything in the domain, this is saying that everything in the domain, for all x means everything in the domain. Now it is saying that it is a crow if and only if it is black. So basically everything in the domain, okay, is black if and only if it is crow. So that is the point. Okay, so I can say that everything in the domain is crow. Wait. So what I am saying, okay, yes, for all x. So I want to see whether this expression is correct expression for this English statement or not. But you can notice what this statement is saying. Okay, this expression is saying that everything in the domain is crow if and only if it is black. Or you can say everything in the domain is black if and only if it is crow. If and only if it is crow. But this is not what we want. Okay, again let me give you a scenario where this expression and this English statement and this expression will have different truth value. Okay, so consider again a scenario. Okay, let's assume this scenario you consider where, so these are the crows. Okay, let's assume, so this is your domain and these are the crows A, B, C, these are the crows, and let's assume you have D, E, F. They are not crow. Okay, Now consider the scenario where this D, this is not a crow, but let's assume this is black. Okay, okay, D is not a crow, of course, you know, D is not a crow, but let's assume that D is black. Now what will happen? Just think about it. And also let's assume all the crow are black. Just assume that all crow are black. Okay, so I am saying all crows are black. Now I am saying, so in this scenario where I am assuming that all crows are black, so ABC, they are black. So in this scenario, our statement, this English statement will become true. Okay, but you can notice that this expression 3 will become false. Why? What is the reason? This expression 3 will become false because you can notice that in the domain has A, B, C, D, E, F. Okay, so in the domain you can notice that because of this element D, for this element D, this is false because D is not a crow, so this is false, and D is black, so this is true. So for this element D, this internal expression, this will become false. So I can say that this expression 3 will become false because in the domain there is element for which this internal expression is false. So this universal quantifier will become false. So you can notice that in this scenario, our statement is true. This English statement is true, but this expression, this first order logic expression is false. So I can again say that this first order logic expression is not correct expression. This is not a correct translation of this English statement. Okay. So finally, now let me tell you what is the correct translation. Okay. As I told you, all crows are black. All crows are black. So the correct translation is very simple. It means that everything in the domain, if it is crow, then it is black. So this is the point. Okay, you can very simply write that everything in the domain, okay, very simply you can write like this: everything in the domain, if it is crow, then it is black. Then it is black. So this is the correct translation. So it means everything in the domain means for all x, if it is crow, then it is black. Okay, so this is the correct translation for this statement. Okay, for this English statement, this expression, okay, let's call this expression 4. So this expression is correct translation. Now you can prove it also very easily. You can prove it. How can we prove it? Just think about it. Okay, so this is our statement: all crows are black. So this is our statement. Now let me show, and this is our expression. Okay, let's call this expression shy. So this is our expression: for all x, if it is crow, then it is black. Okay, again, as usual, the domain, this is your domain, and these are the crows. Let's assume these are the crows. Let's assume A, B, these are the crows, and C, D, these are not crow. Okay, now let me show you that whenever P is true, then shy is true, and whenever P is false, then this expression will be false. So when P is true, then what it means? When P is true, it means all crows are black. So when P is true, then you can automatically see that this statement will also be true. Because when P is true, then all the crow are black. It means, remember, it means that shy cannot be false. In this scenario now, shy cannot be false. Why? Because how can you make shy false? This will be false when there is some element for which this becomes false. Okay, this shy will become false. Shy will become false when there is some element for which this internal expression will become false. And when this internal expression becomes false, this internal expression becomes false when something is crow but it is not black. Okay, remember? So this is an implication statement, and this is false when this hypothesis is true but the conclusion is false. So you can notice that this expression will be false when there is some element which is crow but not black. But you can notice that I am saying that when P is true, P is true means all crows are black. Okay, so when all crows are black, then this situation cannot occur. This situation is not possible. So because this situation is not possible, so shy cannot be false. So I can say that when P is true, then I can say then shy is true. So when P is true, then shy is true. Now let me prove it to you that when P is false, then shy will be false. Let's assume P is false. What it means? P means all crows are black. Let's assume this is false. What it means? It means there is some crow which is not black. Okay, so it means there is some crow. There is some crow which is not black. Okay, now if there is some crow which is not black, then what I can say? Now you can immediately see that there is some crow which is not black. So because of this crow which is not black, I can say that the shy will become false. Shy will be false. Okay, because of this crow who is not black, because of this crow, this will become true and this will become false. So I can say that because of this crow, shy will be false. So this is what we wanted to prove. You can see that whenever P is true, shy is true. Whenever P is false, shy is false. So I can say that this is the correct translation. Okay. So we have seen what we have seen. We have seen that when you have this statement, all crows are black. When you have this statement, this type of statement, when you have, then what is the correct translation? This type of English statement, if you have, then what is the correct first order logic translation? That will be for all x in the domain, if it is crow, if x is crow, if it is crow, then it is black. So this is the correct translation for this. And we have proven why this is true, why this is correct translation. So you don't have to by heart. Okay. Many people, they by heart this. Okay. Many people by heart that with universal quantifier we use implication. But now you know why this case is correct. Okay. Why we use implication with universal quantifier. So this is the reason. I have given you the proof, and I have also told you why other expressions are not correct. Why we cannot use conjunction here, why we cannot use disjunction here, why we cannot use biconditional here. Okay, so all these cases I have told you, and also I have told you the proof why this expression is correct translation of this English statement. Okay, so this is a very important template. So let me explain the template. This is the template. You can notice when you see this type of statement, all A's are B's. So whenever, this is the template, remember, this is a very important template in first order logic. Okay, you can say this is an important template in first order logic. So this is saying that all A's are B's. So how can we convert? So I can convert this like this. For all x in the domain, if it is A, then it is B. Okay, all A's are B's means for everything I am saying that if it is A, then it is B. If it is A, then it is B. So this is a very important template in first order logic. Okay, so I hope you got it. If there is any doubt, you can ask in the comments. Now let's see the next template. Okay, so the next template that we have is some A is B. Okay, for example, some crow. Okay, some crow is black. So consider this example. Some crow is black, or you can say some crows are black. This is another important template. What this is saying? This is saying that some means at least one. So first of all, it means at least one crow is black. Remember, some crows, it means some crows means at least one crow is black. So both these statements are same because some means at least one. Okay, so at least one crow is black. What it means? It means at least one crow is black means there exists an element in the domain. So I can say, okay, this I can say that there exists an element. There exists an element in the domain. Such that it is such that it is a crow, and it is black, such that it is a crow and it is black. So this is the point. Okay, you can see this statement, at least one crow is black. It means there is some element in the domain such that it is a crow and it is a black. It means there is a crow who is black. It means at least one crow is black. Okay, so there exists an element in the domain. It means there exists an element in the domain, there exists X, such that it is a crow, this X is a crow and it is black. So this is the correct translation of this statement. Okay. Now some of you might be wondering, is this the correct translation or not? Okay. For example, some crows are black. Okay. Now some crows are black means at least one crow is black. So for this statement, let's call it statement P. For this statement, can I say this expression 1? Let me write it for this expression 1. There exists a element in the domain. If it is crow, then it is black. Let's check it out. Is this a correct translation? Can you think about it? This is not a correct translation, because remember what this is saying. This is saying that there exists an element in the domain, okay, such that if it is crow, then it is black. Remember, I can write it like this. There exists X, I can write like this. So you already know that P implies Q. Okay, this is equivalent to negation P or Q. Okay, so this is standard equivalence that we have. P implies Q. Implication statement is equivalent to negation P or Q. So this is what you can write here. So this is an implication statement. I can write negation crow X or black X. So what it means? It means that, so this expression that you have, I can say it means that there is some element in domain. So there is some element in domain. There is some element in domain which is either black or not crow. So there is some element in domain which is black or not crow. Which is black or not crow. But this is not what we want. We want that some crow is black. Okay. This is what we want. Some crow is black. At least one crow is black. Okay. But you can notice that this statement is saying that there is some element in the domain which is black or which is not crow. Now let me give you a scenario where this statement and this expression, they will have different truth value. So again, let me give you a scenario. Consider what will happen. Let's assume this is the domain. So domain has everything, and let's assume these are the crows. Okay, so these are the crows. Let's assume A, B, these are the crows. Now assume this C, D, these are not crow. C is not a crow, D is not a crow. Now consider the scenario where, let's assume this A is black, means A is black. It means A is a crow and it is a black. Okay. Sorry, so let's consider another scenario. Let me tell you another scenario. Okay, so now let me give you another scenario. So assume that no, okay, now what I'm saying, assume that no crow is black. Okay, so assume no crow is black. Okay, just assume it. Okay, that no crow is black means A is not black, B is not black. Okay, so this scenario I have given to you. Okay, so A, B are crow, and in the domain we have A, B, C, D. In domain we have everything A, B, C, D. Okay, C, D, these are not crow. Okay, and let's assume that no crow is black. Now in this scenario, what will happen? In this scenario, what will happen to our statement? So our statement will be false, because no crow is black. So our statement is saying that at least one crow is black. So you can notice in this scenario, in this particular scenario, our English statement will become false. But what will happen to expression 1? Expression 1 will be true. Why? Because expression 1 is existential quantifier. There exists X such that If it is not crow, then it is black. You can notice that this expression 1 is true because of this element D. For this element D, this will become false because D is not a crow. So this will become false and this will become false. Hence you can say that because of this element D, this expression, this internal expression will become true. And because in the domain this element D is there, and for this element D this internal expression is becoming true, so existential quantifier will become true. So you can notice that in this scenario expression 1 will become true, but our English statement is false. So we can say this is not a correct translation of this English statement. We can say that this expression is not equivalent to this English statement. Okay, so this is the reason this is not a correct translation. Okay, similarly you can check now if this is okay, then similarly you can check that this is also not a correct translation. Okay, if you write like this, there exists X, it is crow or it is black. Okay, so this is also not a correct translation because this is saying that there is some element in the domain. Okay, remember there is some element in the domain such that it is a crow or it is a black. It is a crow or it is a black. But what we want that some crow is black. This is what we want. So this statement is also false. Okay, this expression is also not a correct expression for our statement. Similarly, you can say that, and you can also notice one thing, that you can also give a scenario where this expression will have different truth value from the given English statement. You can very easily consider a scenario. For example, let me give you a scenario. Okay, let's assume that no crow is black. Okay, you have two crow. Let's assume these are the crow, and let's assume this is C, D. These are not crow. So this is your domain. Just assume that no crow is black. Let's assume, and let's assume that this is okay. So no crow is black. Okay, so let's consider that no crow is black. Now what I'm saying, so just wait. Yes, so I'm saying that let's assume that no crow is black. So even though no crow is black, so in this scenario, our statement, what is our statement? Our statement is some crows are black. This is our statement. This is our original English statement, some crows are black. You can notice that in this particular scenario, our statement will become false because no crow is black, so our statement is becoming false. But this expression, let's call it expression 2, this expression 2 will become true. Why? Because this expression 2 will become true because of this B. This B is a crow, so because of this B, this expression will become true, and that is the reason existential quantifier will become true. So you can notice in this scenario, our English statement is false, but this expression is true. So I can say this expression is not a correct representation of this English statement. This expression is not a correct translation of this English statement. Okay, so this is the point. Now let's consider what is the correct translation. So the correct translation is very simple. Some crows are black. Okay, so this is our statement. Let's call it statement P. Now the correct translation, let me give you the correct translation is this, that there exists X in the domain. There exists an element in the domain such that it is crow and it is black. Okay, now let me prove. Okay, what is the proof? Let me prove that this is a correct translation. Now what I will do? I will prove that whenever P is true, when P is true, then I will prove that when P is true, then psi will be true. See, when P is true, it means some crow is black. Correct? When this statement P is true, it means some crow is black. So you can notice that in this situation, some crow is black. So in this situation, psi is also true. Because that crow which is black, because of that crow, this statement, this internal expression will become true. So existential quantifier will become true. So you can notice When P is true, then this expression is also true. Now let's see when P is false. When P is false, it means no crow is black. Okay. So if no crow is black, now you can notice that because no crow is black, so you can notice that you cannot make psi true. So now psi cannot be true. Psi cannot be true. Why? How can you make psi true? Tell me. Psi will be true. This expression will be true when for some element this is true. For some element this must be true. And for some element, how this will be true? This will be true when it is true and this is true. So you can notice that psi will be true when for some element, so for some element should be crow and it should be black. But you can notice that in this case, when P is false, it means no crow is black. So this internal expression cannot be true for anyone. So this existential quantifier will become false. So I can say that psi is also false. So this is the proof. So we can say that whenever P is true, whenever this English statement is true, our expression will be true. This expression, okay? And whenever this English statement is false, then our expression is also false. So we can say this is the correct expression and this is the proof. Okay? So the final conclusion, let me tell you, this is the final conclusion. Some crows are black. Okay? So the final conclusion is this. This statement, the correct translation of this statement will be, there exists an element such that it is crow and it is black. Because remember, this is at least one crow is black. It means there exists an element in the domain such that it is crow and it is black. Okay, so this is the correct translation. Now let me tell you the standard template. So this is a very popular template. Again, this is another very important template in first order logic. This template we use again and again. So this is very important template in first order logic. So whenever you see this type of statement, some A is B. Okay, some A's are B's. Means at least one A is B. So how can we translate? We can translate, there exists X in the domain such that it is A and it is B. Because this is saying at least one A is B. It means there is some element in the domain which is A and which is B. Which is A and which is B. So this is the correct translation. And this is a standard, this is a very important template. Okay. Now let's see other templates. So the another template that we have is, so we have already seen these two templates. All A's are B's, means for all X, if it is A then it is B. So you can notice with universal quantifier we are using implication, and some A's are B's, means there exists X such that it is A and it is B. You can notice with existential quantifier we are using conjunction. So these two templates we have already seen. Now let me show you another template which is no A's are B's. For example, no crows are black. Let's see this. Okay, what this means? No crows are black. See, this means that there does not exist any crow which is black. Correct? So I can say that this statement I can write like this. This statement I can say that there does not exist an element which is crow and black. Which is crow and black. Correct? Because this is saying no crows are black. It means there does not exist an element which is crow and black. So I can say there does not exist. Okay. So remember. So this means there exists X. Okay. This means there exists X. And this means, this is negation. This means there does not exist X. There does not exist X. Correct? Now, so I can say there does not exist an element. So that is this negation of existence. Negation of existence. I am saying there does not exist an element. It means this is negation of existence. Okay, means there is no existence. So there does not exist an element which is crow and black, which is crow and black. Okay, so this is translation. This is correct translation. There is another translation possible. Let's see. This is saying no crow is black. So I can say that for everyone, for every element we are saying for every element we are saying that if it is crow then it is not black. If it is crow then it is not black. Correct? So this is the point. Because read this, no crows are black. It means for every element we are saying that if it is crow then it is not black. So for every element means for all x. Okay. If it is crow then it is not black. If it is crow then it is not black. Okay. So very simple. If it is crow then it is not black. Negation of black. So this is a very simple translation. So this is also correct. This is also correct. Okay. So both are correct translation. So this is our template. You can notice our template is, this is our template. No A's or B's. So how can I write it? So remember this template. No A's or B's. So this template means for everyone we are saying that if you are A then you are not B. So this is correct. Or I can say that there does not exist any A which is B. There does not exist any A which is B. There does not exist any A which is B. This is also correct. This is also correct. And these both are equivalent. So both are same. Okay. This expression is equivalent to this expression. And this is our English statement. So this is another important template. Let's see the next important template, that is some A's are not B. Okay. So what is some A's are not B? Like some crows are not black. Some crows are not black. So how can we write it? Some crows are not black. Means there exists a crow which is not black. It means very simple. There exists a crow which is not black. There exists a X. There exists an element which is crow and which is not black. So very simple. Some crows are not black means there exists a crow which is not black. Okay. So this is very simple. So what is the template? The template is very simple. Some A's are not B's. This is the template, right? So template is like this. Some A's are not B's. So it means there exists some X. Okay, there exists some X such that it is A and it is not B. Okay, so at least one A is not B. Okay, so this is at least one A is not B. Some A's are not B's. So this is the template. So we have seen all these 4 templates and these are standard templates. So let me just tell you again, these are very standard templates and we use them again and again and again. Okay, so these 4 templates we have seen. First is all A's are B's. It means all A's are B's. It means for all X, if it is A then it is B. If it is A then it is B. You can notice with universal quantifier we use implication. Okay. Next what is that? Some A's are B's. Some A's are B's. What it means? It means at least one A is B. Means there exists an element which is A and which is B. There exists an element which is A and B. So you can notice with existential quantifier we use conjunction. With universal quantifier we use implication. With existential quantifier we use conjunction, and proof I have given to you. Already I have proven it. Okay. So you should understand the proof. you should understand the proof also, and also these basic templates you must keep in your mind also, because we use them again and again. Next, no A's or B's. What it means? No A's or B's. It means for everyone we are saying that if you are A, then you are not B. Then you are not B. And this is same as saying that there does not exist any A which is B. There does not exist any A which is B. There does not exist. There is no existence of any A which is B. Next, some A's are not B. Some A's are not B's. It means there is at least one A which is not B. There exists X which is A but not B. So this is the simple point. So I hope all these points are clear, and the proof should be understood. Remember, once you understand the proof, very easily you can do any variation. In the exam they can ask you any variation, any tricky question they can ask you. If you understand the proof, then you can handle it. Also, these standard templates we use again and again and again, so you must also keep them in mind. Okay, so let's see some examples. Now let's assume these are the predicates: orange X, cat X, fluffy X. So these are the predicates that are given to us. Orange X means X is orange, cat X means X is cat, fluffy X means X is fluffy. Now let's see this. Every orange cat is fluffy. Every orange cat is fluffy. It means for all X, for all elements in the domain, if it is orange cat, I can say, if it is orange cat, I can say that if it is orange cat, then it is fluffy. Correct? Very simple. Every orange cat is fluffy means for everyone we are saying that if it is orange cat, then it is fluffy. Now very simple. Okay, for all X, if it is orange and it is cat, okay, so you can see if it is orange and it is cat, then it is fluffy. So very simple. So the point is very simple. Every orange cat is fluffy means for everyone we are saying that if it is orange cat, then it is fluffy. And you can notice these are the predicates that are given. Orange X means X is orange, cat X means X is cat, fluffy X means X is fluffy. So orange cat means it is orange and it is cat. So for everyone we are saying if it is orange and it is cat, then it is fluffy. Let's see the next. No orange cat is fluffy. It means we are saying for everyone we are saying that if it is orange cat, then it is not fluffy. Correct? So how can I write it? Very simple. For everyone we are saying that if it is orange and it is cat, then it is not fluffy. So very simple. Correct? You can also say that no orange cat is fluffy. It means there does not exist anyone. There does not exist. There is no existence of orange cat who is fluffy. Okay? So there does not exist anyone who is orange also, who is cat also, and who is fluffy also. So there does not exist any orange cat which is fluffy. There does not exist any X which has all these three properties. Okay, so I can say there does not exist any orange cat which is fluffy. So this is another way of writing. So these are standard templates that we are using. Some orange cats are fluffy. It means there exists an X such that it is orange cat and it is fluffy. Okay, so I can say that it is orange cat means it is orange and it is cat and it is fluffy. Correct? At least one, okay, there exists some element which is orange cat and fluffy, means which is orange and which is cat and which is fluffy. Some orange cats are not fluffy, means there exist some orange cat which is not fluffy. So there exists some orange cat, means it is orange and it is cat, but it is not fluffy. Not fluffy. Okay. So there is some element which is orange cat but not fluffy. Okay. So this is how you can write standard templates. Now let's see another template, that is, okay, let's see this. Not all crows are fluffy. What it means? This template, let's see. Not all crows are black. What it means? Not all crows are black. It means not all crows are black. It means some crows are not black, right? This is saying that not all crows are black. Not all crows are black. It means some crows are not black. Some crows are not black. So remember, this and this both are same, because this statement is saying that not all crows are black. It means that there are some crows which are not black. Okay, some crows are not black means there exists some crow which is not black. Correct or not? Okay, so very simple. So both are same, remember. So now he is saying not all orange cats are fluffy, means it means some orange cats are not fluffy, right? Because this is saying not all orange cats are fluffy. It means some orange cats are not fluffy. And this you can very easily write. There exists X which is orange cat and not fluffy, which is orange cat, which is orange and which is cat and not fluffy. Negation of fluffy. Very simple. Next, this template. Okay, let's see this template. All and only crows are black. Okay, just see this template. All and only crows are black. What it means? It means that first of all crows are black. Second, only crows are black. So remember, this means all crows are black and only crows are black. Means if something is black, then it is crow, and if it is crow, then it is black. So remember, all crows are black means if it is crow, then it is black. Only crows are black means if it is black, then it is crow. So very simple point. All and only crows are black. It means we can say that for all X, we can say that it will be crow if and only if it is black. For all X, we are saying, for everyone we are saying that it is crow if and only if it is black. So this is the simple point, because remember, this is saying all crows are black and this is saying only crows are black, means every crow is black. If it is a crow, then it is black. Second, only crows are black. It means if it is black, then it is crow. So there is biconditional here. So something is crow if and only if it is black. Something is crow if and only if it is black. So I can say that for everyone we are saying that it is crow if and only if it is black. So this is new template that we can say. We can say that all and only A's are black. A's are B's. Okay. So this is a new template. And what this template is saying? This template is saying that all A's are B's. So if it is A, then it is B. All A's are B's. And this is saying only A's are B's. Only A's are B's means if it is B, then it is A. Okay. So very simple. So the point is very simple, that we are saying for everyone we are saying that it is A if and only if it is B. So this is the template. Very simple template. Because all A's are B's. If it is A, then it is B. Only A's are B's means if it is B, then it is A. So all and only A's are B's. So this template is also important. And let's see the last template, that is only crows are black. Let's see this. Only crows are black. What this statement means? First of all, understand this. Only crows are black. First of all, what it means? It means only crows are black. Means if it is not crow, then it is not black. So I can say if it is not crow, if it is not crow, then it is not black. Because read this statement, just read this. Only crows are black. Okay, only the crows can be black. So if it is not crow, then it is not black. Then it is not a black. Correct? The same statement in contrapositive manner we can write. Because remember, every statement is equivalent to its contrapositive. So this same statement I can write that if it is black, then it is crow. If it is black, then it is crow. Then it is crow. So very simple. So remember this statement that you can see. Only crows are black. It means if it is not crow, then it is not black. Not crow, not black. So I can also say contrapositive. Okay, the contrapositive of this statement will be if it is black, then it is crow. So now you can write for everyone we are saying that for everyone we are saying that if it is black, then it is crow. For everyone, this is what we are saying. So this is how you can write. Or you can write like this. If it is not crow, then it is not black. Means for everyone we are saying that if it is not crow, then it is not black. So both are same. This and this both are same. So the template, let me tell you the template. Template is very simple. Only A's are B's. Only A's are B's. So this is our template. Only A's are B's. It means only A's are B's. Means if it is not A, then not B. So very simple, remember. If it is not A, then it is not B. Similarly, if it is B, then it is A. Because the contrapositive, remember, what will be the contrapositive? The contrapositive. This contrapositive means if it is B, then it is A. So first you should understand the meaning. So this is the meaning. Only A's are B's. Means if it is not A, then it is not B. And contrapositive means if it is B, then it is A. Now very simple. So you can write like this. So for all elements we are saying that if it is B, then it is A. And this same statement I can write for all elements we are saying that if it is not A, then it is not B. So this is the template. Correct? So this template is also important. So let me tell you. Let's see this example. All and only orange cats are fluffy. All and only orange cats are fluffy. It means for everyone we are saying that it is orange cat if and only if it is fluffy. Because it is saying that all orange cats are fluffy, only orange cats are fluffy. Means for everyone we are saying that it is orange cat if and only if it is fluffy. Okay, and this I can write like this. For all x, I can say orange cat means it is orange, it should be orange, and it should be cat. Okay, if and only if it is fluffy. So this is the expression. So very simple. So all templates we have seen, every template we have seen. I hope you understood all the points. So with proof we have seen, with understanding we have seen all these. Okay, let me write down the summary of all the templates that we have seen. The first important template we have seen is all A's are B's. So this is the first template. All A's are B's. It means for everyone we are saying that if it is A, then it is B. Okay, for everyone we are saying that if it is A, then it is B. You can notice with universal quantifier we are using implication. Okay, second, some A's are B's. This is another important template. Some A's are B's. It means at least one A is B. It means at least one A. There is something which is A and which is B. So at least one A is B. At least some element is A and B. Okay. Next, The next template is no A's or B's. This is the next template. It means this I can write in two ways. The first way is for everyone we are saying that if it is A, then it is not B. Okay, or I can say that there does not exist any A which is B. There does not exist any A which is B. There is no existence. No A's or B's means there is no existence of A's which are B's. The next template is some A's are not B's. Some A's are not B's. It means some A's are not B's. It means there exists some A which is not B. There exists some A which is not B. Next, not all A's are B's. Not all A's are B's. What it means? Not all A's are B's. What it means? Okay. It means that again the same. Not all A's are B's. It means some A's are not B's. Remember? So this statement means some A's are not B's. And this I can write the same. Both are 4 and 5. Both are same. It means some A's are not B's. Okay. So some A's are not B's. Correct? Okay. Next, let's see this same statement. If you see this same statement, not all A's are B's, I can also write in another way. Not all A's are B's. How can I write? I can say negation of this. Correct? What I can say? I can say negation of this. And what is this? All A's are B's means for all X, if it is A, then it is B. So you can notice, not means negation. Okay. So not all A's are B's. It means not all A's are B's. Okay. So not of all A's are B's. Remember, this is same as saying that there exists X which is A but which is not B. Both are same because you can see here. Okay. This and this both are equivalent. Okay. So the next template, the sixth template is only A's are B's. It means that, okay, this is very simple. It means that for everyone we are saying that only A's are B's. Only A's are B's means if it is not A, then it is not B. If it is not A, then it is not B. Similarly, I can say that only A's are B's. What it means? It means that if it contrapositive, if it is B, then it is A. So this template also we have seen. And the last template is all and only. All and only A's are B's. What this means? This means all A's are B's means all A's are B's and only A's are B's. Only A's are B's. It means if it is not A, then it is not B. Or you can say if it is B, then it is A. So remember, all A's are B's. If it is A, then it is B. Only A's are B's. It means if it is B, then it is A. So I can write that for everyone, if it is A, for everyone I am saying that if it is A, if and only if it is B. So this biconditional will come. Okay. So in the next lecture, we will take many examples. Okay. I hope you understood all these points. Okay. So if there is any doubt, you can ask in the comments. And watch the next lecture for many examples. I am going to take a lot of examples based on all these templates. These templates will be used again and again and again. So these are important. Okay. Feel free to ask me in the comments if there is any doubt. Thank you everyone.